Hey guys, so this video is gonna explain our recent project that I've been working on, which kind of aims to improve the memory architecture within the chatbots that we commonly interact with, such as OpenAI or even the regular ones that we run locally. I'm pretty aware that OpenAI does have its own memory implementation, but I think it's pretty primitive in its implementation, so what I've kind of been working on is more of a knowledge-based graph approach to this. This video shows a synthetic test case that I made using Gemini, where I try to first retrieve an information that wasn't in the knowledge graph, and then I put in the information, and then it goes ahead and sorts through it and actually finds the information. The question being highlighted right now is the one that I'm going to evaluate the whole test with, and you'll see that it works pretty well. And if you can see on the right side, you can see the nodes, and this is how the general um, knowledge persistency works. Like, this is the memory of the entire LLM, and this is kind of different from OpenAI's approach because I am assuming they just do a cousin similarity between them and they just do embeddings of the individual knowledges. So you can see that when we're trying to run this first failed test case that it's gonna run for quite a while, and I'm gonna speed up the video to accommodate for that. So it reached the max steps. In other words, it just timed out, as expected because this information does not exist. So what we're gonna do in a bit is actually input the information in, and we're gonna give it another shot. Okay, so let's finally input the new information in, and let's try it out again. Now what you're gonna notice is the difference in terms of how the LLM is processing this information, where currently it's gonna add to the knowledge graph right now. So let it process for a little bit, and I'm gonna open this right now. And you can see that it's created several different nodes for the doctor. It created the occupation, it created the message, and it does a lot more work in the background in order to update the knowledge graph effectively with the information that it needs to retrieve it in the future. So let's go ahead and ask the same question once again to the LLM where it previously failed, and you'll see that this time it's going to get the question pretty fast and pretty correct. And I think that's the eventual goal of this whole project, is to be able to traverse across many different nodes within the knowledge graph and the relationships and correctly identify the relevant information needed for the query that the user is presenting.